Hi everyone, welcome to my channel. Today we are going to discuss the how JVM internally working. So let's start. Uh, just we are taking an example of student.java class. Inside that we have written some source code, and after writing this source code we need to generate the .class file. For that sake we are writing one command javac student.java. Then student.class file gets generated. Now we need to pass this .class file to the JVM. For that sake we are writing one more command java student. By using this command we are telling to the JVM, this one is the input for you, please take it and execute this. Now after that then three things happen. First, it is going to load the student.class file. Then it will be started the linking the many things. Inside that three steps will be there. First one is verification, second one is preparation, and third one is resolution. And final, after the linking phase, that one more phase is there, that is initialization phase. So we are going to elaborate the loading phase. Let's start the loading phase. For the loading there will be class loader subsystem will be there. Inside that three class loader will be there. First one will be the application class loader, and another one is application loader's parent class is there, extension class loader, and one more class loader is there, that is bootstrap class loader. First of all, request will come to the application class loader. Now it will delegate the request to the extension class loader. Again, extension class loader will delegates the request to its parent, that is bootstrap class loader. Here bootstrap class loader will search the student.class file to this bootstrap class path. If .class file is present, then it will loads the student.class files. If it is not present, then it will delegates the request to its child class, that is extension class loader. And extension class loader will check the student.class file at the extension path. This one is the extension path is there. If student.class file is available, then it will loads the student.class file. If student.class file is not available there, then again extension class loader will delegates the request to the application class loader. Now application class loader, it will try to load the .class file from the application path area. If the application class loader is found the student.class file at its application path, then it's okay, it will load the .class files. If not present, then finally it will throw the exception like no class def found or not class found, exception will be thrown. Then loading phase will be will be completed, and after that what happened, linking phase will be there. What link inside the linking phase, three steps will be there. First one is verification phase. Inside the verification phase, what happened, while loading the dot class files into the memory area, it will check codes which we have written in dot class file is valid or not. If it is not valid, it will throw an exceptions inside the verification phase. Now another phase is that preparation phase. Inside the preparation phase, what happened, whatever the static values will be there inside the method area, for those values memories are allocated to them and default values will be assigned. In the preparation phase. After the preparation phase, resolution phase will be there. Inside the resolution phase, what happened, inside the class multiple variables will be there. For those variables, objects will be created and many another values will be there. For that, like what is happening, those objects will be referenced by the exact values instead of symbolic reference. Now everything will be completed in the resolution phase, and after the linking phase, one more phase will be there, that is initialization phase. Inside the initialization phase, what happened, after allocating the memories for the static variables, exact value will be assigned to that variables. After initialization phase is completed, here we can see that multiple memory areas will be there. Here the first memory area is there, method area, then heap area, then stack area, then PC register area, then native method area. Inside the method area, what is happening, while loading the dot class files by the boost any class loader, those files will be loaded into the method area. Inside the method area, class level information will be there, like what is the name of the class, how many constructors are there, which types of instance variable will be there, and a static information will be there. After the method area, one more memory area is there, that is heap area. Inside the heap area, whatever objects are created in the Java program, those will be stored into the heap area only. Now another one is stack area. Inside the stack area, local variables will be stored into that, and also for the every methods, one separate thread will be created. And after completion of that method, thread will be destroyed. And next one is the PC register area. It holds the reference of the next, or we can say current executing instructions information. And last memory area is native method area. It holds the information of native methods. Native methods, we can say those methods which is written in the some another language like C or C++. After they allocating the different types of memory area, then comes then one more phase comes to the picture, that is the execution engine. After loading and the allocating the memories, execution engine comes to the picture. Inside the execution engines, interpreter will be there, and JIT compiler will be there, and garbage collector will be there. Then we can say execution is the combination of these three things. First, interpreter comes to the picture. What interpreters will do? It will reads the byte codes from the method area and interpret to its machine code. Here interpreter will interpret it line by line. Here one thing is there. If one method is coming multiple times, then every time it is going to interpret them, which is not good. For that sake, removing these types of the issues, JIT compiler comes to the picture. What JIT compilers will do, if one method is coming multiple times, it will starts a count which is going to increment for every occurrence of that method. If that occurrence or count will be increased and reached to its threshold number, then those methods comes to the hotspot area. Hotspot area means JIT compiler will what JIT compiler will do, it will tells to the interpreter that if those methods are coming, then just inform me. If those methods are coming, then JIT compiler what it will do, it will not interpret and it will just execute that method from taking the reference from the last executed values. So now according to that, JIT compiler will helps us to improve the performance of accessibility or execution of that any program. Now inside the execution engine, one more thing is there, that is garbage collector. We know garbage collector is responsible to destroy the unreferenced objects. One more thing is that execution engine is, while executing or interpreting the anything, sometimes such types of methods are coming which is not written in the Java program, so we need to execute those things. For that sake, it requires the method informations which is written in the another libraries. So those information will be collected by the Java native interface. So Java native interface work as a intermediator between execution engine and native method libraries. So it will establish the communication between them, and finally Java programs gets executed. So whatever things we have discussed here, that is the only Java Java virtual machines internal architecture. So this is the thing happening in the JVM architecture. Thank you. So guys, hope it is helping to you guys. So I'm telling that if you will share these videos videos, then it will be going to help your friends and any another persons. Just give some comment on my hard work. Thank you.